Hey, so right now we're going to look at combining rational expressions. So hopefully we remember rational expressions are fractions, so we're trying to combine again fractional or fraction expressions or whatever you want to call it. So hopefully we remember how to combine fractions when you have numbers. So say we have something like 1/6 plus 3/8. If I have something like 1/6 plus 3/8, I have to find a common denominator. They have to be out of the same part. So if I look at 6 and 8, I just hopefully know that the common denominator should probably be 24. They both divide into 24. I know with fractions, the really only thing I can do is multiply the top and bottom by something. So with 6, I'm going to multiply it times 4 to get my 24. With my 8, I'm going to multiply it times 3 to get my 24. Top and bottom again, and I should get 4 plus 9 or 13 over 24. See if you can simplify it. I can't. But hopefully the number part makes sense. So let's see what we can do with algebraic terms. So we know again that if we're going to find a common denominator, we're going to have to multiply by something. So it would again make sense for us to write this as multiples, which again would mean to factor. So if I look at this, I'm going to factor as best I can. I have 1 over x squared minus 9. I'm going to factor that to 1 over x plus 3, x minus 3. Then I have 5 over x squared plus 5x plus 6. I'm going to factor that to x plus 3, x plus 2. And now I'm going to try to find a common denominator between these two things. So the common denominator again should be something that I can multiply each one of them by. It doesn't have to be the same thing. Over here we had the 6 times 4 and 8 times 3, but something I can multiply them by so they have the same exact denominator. So I'm going to look at each of my denominators. My first one has a denominator of x plus 3, and my second one has a denominator of x plus 3, so they have that in common. My first one has an x minus 3, and it doesn't have an x plus 2. My second one has an x plus 2. So I'm going to go ahead and multiply that first one by an x plus 2. I'm going to do the same thing to the top. And now I'm going to say, okay, well, they both now have an x plus 3, already underlined that. Now they both have an x plus 2. So they're getting more in common. So I'm going to multiply the second one by an x minus 3. So if I do this, again, I'm going to check. Yeah, they got everything common now. So what you're looking for when you find common denominators, really, what are they missing? Is there anything that one denominator is missing that the other one has? If it is, multiply it by it. Okay, so let's go ahead and do the math. 1 times x plus 2 is x plus 2. 5 times x plus 3 is 5x minus 15. So I can simplify that to give me 6x minus 13 all over my common denominator, x plus 3, x plus 2, x minus 3. See if you can simplify it. And I know I can't simplify it. If I could simplify it, that means that I would be able to factor out that numerator. Okay, so let's try a second one. Again, I'm going to write them so they are factored. So 3 over x minus 7, x plus 1, and I'm going to write the second one so it's factored. X minus 7, x plus 2. So again, I want to get a common denominator. I want to multiply to get my common denominator. So I want to get a denominator that they both have that looks exactly the same. So they already have the x minus 7. So the first one does not have an x plus 2. So I'm going to multiply the first one by an x plus 2. Okay, now they both have an x minus 7 and an x plus 2. Well, the second one's missing an x plus 1. So I multiply the second one by an x plus 1. Okay, so now they both have an x minus 7, x plus 2, and x plus 1. So now I have a common denominator. Okay, so my common denominator, she says, x minus 7, x plus 2. It doesn't really matter which order. I could write it x plus 2, x minus 7, x plus 1. Really could write it any of the ones being first. I'll go ahead and multiply the numerator though. 3x plus 6 plus x squared plus x. and combine like terms. X squared plus 4x plus 6 over my common denominator. As I said, doesn't matter the order. For fun, I'll just write the x plus 2 first. So x plus 2, x minus 7, x plus 1. Check to see if you can simplify it. Can you factor that top? Is there anything that multiplies to 6 and adds to 4? No. So I can't simplify it. This is just my answer. Okay, and I guess I didn't circle my previous answers. Let's circle that. Try the next one. So again, we're just combining. This time we're subtracting, but shouldn't be any different. So I'm going to first start off by writing them with factored denominators, or factored terms. I can't factor any of these numerators, so I've just been leaving them alone. First one is 2x over x squared plus 4x plus 4, so x plus 2. X plus 2. Second one is 4x plus 8. Not a quadratic this time, so I can't factor into two binomials, but I do have a 4 that could come out. I could pull that out. It would divide into both terms. So I'm going to write that as 4 times x plus 2. Okay, so now, again, I'm going to see what they have in common. X plus 2, one of them is in common. So that is good. This first fraction is missing a 4. It's going to need a 4 there to look more like the second one. So now they have one x plus 2 and one 4 in common. So all I need now is a second fraction to have an x plus 2. So I'll multiply the top also by the x plus 2. So now they have the 4, the x plus 2, and the x plus 2 in common. So I have a common denominator. I'm going to simplify my common denominator and write it as 4 times x plus 2 squared. That's less writing, so it's simpler. And I'll multiply out my numerator, 8x. Don't forget when I'm multiplying, this is a minus. This minus will have to go and be distributed throughout that parentheses right there. So you might want to think of this as a minus 3 going through. So I'm going to have minus 3x minus 6. So again, combine like terms, 5x minus 6 all over 4 times x plus 2 squared. See if you can simplify. Can I factor the numerator at all? No, I can't. So this is just done. Okay, let's try this huge one down here. We got two minuses going on. So okay, I'm going to start off the same way and factor. 6 over x squared plus 3x. It is a quadratic because it has the x squared, but it has no constant over here, so I can't do the two binomials. So I'm just going to pull out the x. Whenever I'm missing a constant, I can always just pull out that x. So x times x plus 3 minus, I have x squared plus 4x plus 3, so that will give me x plus 4, x plus 1, and I just screwed up. That would give me x plus 3, x plus 1. I can do math. Okay, factor the last one. 1 over x squared minus 1 would give me x plus 1, x minus 1. So I need to do the common denominator. So I'm going to look and I'm going to say, okay, so my first one has an x plus 3. This one has an x plus 3, so that works. It does need, it's missing an x plus 1. So it's going to need an x plus 1. And now it looks a lot more like the second one, which is good. So if I look at this, it has the x plus 1 with the last one, but it also needs an x minus 1. So it's going to be a huge common denominator. Okay, so now it's got, first one's got everything that the next two have. Let's look at my second one. My second one has the x plus 3. Good, it has that from the first one. Has an x plus 1, but it's missing an x. It needs an x. And it's going to need that x minus 1 from the last one. So I'm going to need an x and an x minus 1. Okay, so the last one has the x plus 1, x minus 1, but it's missing an x and then x plus 3. So I'm going to need an x and an x plus 3. Okay, this is going to be a little bit ridiculous. So our common denominator is x, x plus 1, x minus 1, x plus 3. Again, doesn't really matter the order, I just decided to write it like that. I like the x in front. Now I got to multiply a whole bunch of stuff out. So I got x minus 1, x plus 1 times 6. I'm going to do this in 2 stages, so I'll get 6 on the outside. X plus 1 times x minus 1 is just x squared minus 1. Okay, the next one, I can do this in one stage. This is the minus 4x times x minus 1. Don't forget the minus is going to go with that 4x. So minus 4x squared plus 4x. And then the last one is a minus 1x times x plus 3. So minus x squared minus 3x. Okay, so I'm going to go ahead and distribute that 6 through. If I do that, I'm going to get 6x squared minus 6 minus 4x squared minus, plus 4x minus x squared minus 3x. All over my common denominator. I'm being lazy and just doing CD. Now I'm going to go ahead and combine like terms and see if it's factorable. 6x squared minus 4x squared minus x squared should just give me an x squared. Positive 4x minus 3x should give me a plus positive x minus 6. All over my common denominator. This is factorable. I can factor this. I would get x plus 3, x minus 2. If I write that over my common denominator, I'm going to write my x plus 3 first just so they're over top of each other. My x plus 1, x minus 1. So my x plus 3's will cancel. So I could simplify this one. And I'm left with x minus 2 over x plus 1, x minus 1. So that turned out a lot simpler answer in the end than that huge problem that we started with. Alright, so the main questions I get on this is why does the negative go with that 4? And if you remember from, well again, fractions, if I have 1 over 3 and the fraction is negative, it's a floating negative. It can go to the top because negative 1 divided by positive 3 is a negative 1/3. A positive 1 divided by a negative 3 is also a negative 1/3. So when we're working with fractions and we have a negative fraction, if you have something like negative 1/3, we always put the negative with the top. The other question I get is, well, when we're at, say, this step right here, let's go back to this problem, why don't we just cancel out the x minus 2's? Wouldn't that make it simpler? So why not cancel? And the reason we don't want to is because we would be going backwards. If we canceled these out, we would just be doing the exact opposite of what we just did, which was multiplying x plus 2 times x plus 2. And the whole point is to get the denominators to be the same. So if we canceled out, the denominators would not be the same again. So we want to go ahead and distribute and combine like terms on the numerator and just keep the denominator as it is. There's no reason to ever multiply out the denominator. As we saw in the last one, we don't want to multiply it out because sometimes it will simplify, sometimes stuff will cancel. Okay.